Welcome to my YouTube channel, a Brainery of Civil. Today I am going to solve the fourth assignment of Geotechnical Engineering 1 or Soil Mechanics. Okay. So the data for question number 1 and 3. So this is a common answer questions. Okay. So you need to get question number 1 correct answer. You can use this answer in the question number 2, then only you will get. So if you got wrong answer in the question number 1, entire 3 questions will be wrong. Okay, so these are all linked answer questions. So the question number 1 answer linked with question number 2. Question number 1 and 2 answers will be linked with question number 3. Okay, so the most important questions are these type. So they'll ask in the GATE exam. Okay, so now the ground conditions at a site are shown in figure. The water table is at ground level. So that is, he has given water table is at ground level and the sand. Here the soil is a sand. Water content W is equal to 30% and specific gravity of solids is equal to 2.67. So there is a point P at a depth of 6.5 meters. So the first question is saturated unit weight of sand above the site is. So what he has given, water content and G. We'll try to calculate. We have one formula, E is equal to Wg by S. S is equal to 1 because saturation condition. So that is degree of saturation is 100%. So now we have formula saturated unit weight is equal to G plus ES divided by gamma W into 1 divided by 1 plus E into gamma W. So we can write ES is equal to WG. Clear? In place of ES, I will write this is WG. In place of E, as S is equal to 1, E is equal to WG. Clear? So I will substitute the values 2.67 plus 0.3 into 2.67 into 9.81 divided by 1 plus 0.3 into 2.67. So I will get the answer as 18.9 kilonewton per meter cube. Answer A for question number 1. Simple question. And now the total stress at a point P above the site is. So the point P is laid at a distance 6.5 meter. Total stress will become sigma is equal to the soil is in the saturated condition. Gamma saturated into H. Gamma saturated is 18.9. That is, I am using here the answer of question number 1. Okay, into 6.5. Total stress will become 122.9 kilonewton per meter cube. So the answer will be answer D for question number 2. Okay, and effective stress at the same point. We know effective stress sigma bar is equal to total stress sigma minus U is equal to pore water pressure. So to get this, we need to calculate U at 6.5 meter is equal to gamma W into H. Gamma W is 9.81 into H is equal to 6.5. You will get it is 63.765 kilonewton per meter cube. So effective stress sigma bar is equal to sigma minus U. In earlier problem, we have got the value of sigma, that is 122.9 and U is equal to 63.765, that is equal to 59.135 kilonewton per meter cube. Clear? So the answer is A for question number 3. Okay, the most important model is this model. Okay, in GATE compulsory you will get at least 3 to 4 linked in answer questions. Okay, be careful. And coming to question number 4. Here also 4 to 6 the data is same. 4, 5, 6 questions are common data questions. A sand layer found at a sea floor under 16 meter water depth. So that is the water depth here it is 16 meters. and there is a sand layer here. This is sand layer. Is characterized with relative density. So that is relative density D suffix R is equal to 30% and maximum void ratio E max is equal to 1.0. Minimum void ratio E minimum is equal to 0.50. Specific gravity of solids G is equal to 2.65. The saturated unit weight, and he has given gamma W is equal to 9.81. Clear? So now we need to calculate saturated unit weight. So by using this information, relative density, E max, E minimum, can we get anything? That is, we can get natural void ratio. So relative dr is equal to E max minus E natural divided by E max minus E minimum. So dr he has given it is 30%. I am writing it is in 0.3 and 1 minus E natural divided by 1 minus 0.5. So from this equation, E natural, that is void ratio in natural condition, is equal to 0.85. Clear? So this we got from this relative density formula. And we know gamma saturated is equal to G plus ES into gamma W divided by 1 plus E. So G he has given 2.65 plus E is equal to 0.85 into S we need to take it is 1 because the sand is completely saturated because it lied below the sea, into gamma W is 9.81 divided by 1 plus 0.85. So that is equal to gamma saturated is equal to 18.56 kilonewton per meter cube. So the answer is A for question number 4. Now coming to question number 5, the effective stress at 20 meter below the sea floor. So this is water. How much depth? 16 meter. 20 meter below the sea floor means this is a floor of the sea. Sea floor. So this is 20 meter. So we already calculated here gamma saturated is equal to 18.56. So now effective stress is difference of total stress minus pore water pressure. So first we will calculate total stress. Sigma is equal to gamma W into 16 plus gamma saturated into 20. Gamma W is 9.81 into 16 plus 18.56 into 20. You will get it is 528.16. And pore water pressure U is equal to gamma W into 20 plus 16. Total depth you need to consider. So that is 9.81 into 36. You will get it is 353.16. Now effective stress sigma bar is equal to sigma minus U. Sigma bar is equal to, sigma is 528.16 minus U is equal to 353.16. Obviously you will get it is 175 kilonewton per meter cube. Clear? Answer D for question number 5. Now next question, the most important application type question. The change in effective stress at 20 meter below sea floor into the sand layer if the sea level permanently rises by 3 meters. That is, this will become permanently rises by 3 meters means earlier there is 16 meters water depth. Now it will become 16 plus 3. It is 19 meters. And below 20 meters 1 point is there. So here now total stress is equal to gamma W into, earlier we have taken it is 16 plus 20. Now we need to take it is 19 plus, for 19 it will be water and gamma saturated into 20. So you will get, by substituting the values you will get it is 557.59. And pore water pressure U is equal to gamma W into, earlier you have taken it is 20 plus 16. Now it is 20 plus 19. So it will be 382.59. Effective stress in this case is 557.59 minus 328.59. Again it will be 175. So in earlier problem it is sigma 1 bar as 175, and now in this problem sigma 2 bar as 175. So by rising water table 3 meters permanently, there is no change in the effective stress. Okay, so change in effective stress by rising water table permanently by 3 meters. So change will be sigma 1 bar minus sigma 2 bar, that is 175 minus 175 is equal to 0. Clear? So here we need to draw a conclusion that by rising water table by some depth, there is no change in the effective stress. Clear? Next question. A 2 meter layer of soil with saturated unit weight 20 kN per meter cube is subjected to an upward seepage head of 2.2 meters. So this is 2 meter. The saturated unit weight is gamma sat is equal to 20 kN per meter cube. Seepage head. Here at the bottom, there is a seepage head. It will be 2.2 meters. Clear? So that is seepage is from bottom to top. The depth of coarse sand would be required above the soil to provide factor of safety. He has given factor of safety is equal to 2.5. So that is here we need to provide certain depth of the coarse sand layer to obstruct this seepage force by a factor of safety of 2.5. So now the solution is factor of safety is equal to 2.5. He has given, that is total downward force divided by total upward force. So I am taking this coarse sand layer height is x, and he has given the dry unit weight of this coarse sand layer is 16 kN per meter cube. So total downward force is equal to 16 into x plus 20 into 2 divided by upward force is 2.2 is the seepage head into gamma w. I am taking it is 10. Gamma w here I am taking is 10. So in this entire equation you can get x is equal to 0.9375. The most important 2 marks question. Of course the number of steps in this problem are only hardly 2 to 3. Okay, the concept is there here. Okay, so the answer B for question number 9. Next question. The void ratios of samples at loosest and densest state, that is loosest is E max is equal to 0.87 and densest is E minimum is equal to 0.67. Specific gravity of solids G is equal to 2.67. The ratio of critical hydraulic gradient in the loosest state, that is ICR in loosest state divided by ICR in densest state. We need to calculate this. Generally we have a formula, critical hydraulic gradient is equal to G minus 1 by 1 plus E. So now in loosest state, so first in loosest state, ICR is equal to 2.67 minus 1 divided by 1 plus, in the loosest state void ratio is maximum, so 0.87. So you will get it is 0.89. So this is ICR in loose state. Now in dense state, so ICR is equal to Z minus 1 by E plus minimum, E minimum 2.67 minus 1 divided by 1.67. So it will be 1. So now ICR in dense state. So what he is asking, loosest state to the densest state, that is 0.89 divided by 1, you will get it is 0.89. So clear. So the answer is B. Simple formula, critical hydraulic gradient is equal to G minus 1 by 1 plus E. Based on this formula only the entire problem will go. Next, ninth question. A masonry dam has a pervious sand N is equal to, that is porosity is equal to 0.40 and specific gravity of solids GS is equal to 2.67. The maximum permissible upward gradient. So generally we call the upward gradient, permissible upward gradient, it is exit gradient. So E exit gradient we need to calculate. Factor of safety is 2 against boiling. Okay. So now first of all he has given porosity. By using porosity can we get any E value, that is void ratio value, N by 1 minus N, that is 0.4 divided by 1 minus 0.4. You will get it is 0.4 divided by 0.6, it is 2 by 3. So E is equal to 2 by 3, that is 0.67. Critical hydraulic gradient ICR is equal to G minus 1 by 1 plus E. 2.67 minus 1 divided by 1 plus 1.67. So 1 plus 0.67. You will get it is 1. Critical hydraulic gradient is 1. Now we have one definition. Factor of safety is equal to critical hydraulic gradient divided by exit gradient. So I exit gradient is equal to ICR divided by factor of safety. ICR we got it is 1, factor of safety is 2. I exit gradient is equal to 0.5. So the answer is D for question number 9. Clear? Last problem. Don't be afraid by seeing the diagram. Okay, it's very simple problem. You need to remember only one formula. So see, he is mentioned that seepage flow condition is shown in the figure below. The saturated unit weight of the soil, gamma saturated is equal to 20 kN per meter cube. The effective vertical stress on plane XX. Okay. So we already calculated effective stress, total stress at core water pressure. When there is no seepage. Now in this condition there is a seepage. So whether the seepage is upward or downward. Okay. So here if you observe, the water level is higher. Here the water level is lower. Obviously the flow will from higher water level to lower water level, that is from here to here. Okay, so this seepage is upward or downward? Observe it. So it is obviously upward. So seepage is upward seepage. So when the seepage is upward seepage, the effective stress will decreases. So by how much means? So effective stress sigma bar is equal to gamma submerged into Z minus IZ gamma W. So this is the formula. If the seepage is in the downward direction, you need to use plus in this equation. So gamma submerged is equal to saturated gamma sub is equal to gamma sat minus gamma W. Okay, so gamma sat 20, gamma W is 9.81. What is the depth of the sample? Z is equal to 4 minus I hydraulic gradient is equal to H by L, that is head loss by length of the sample. Head loss is equal to 3.5 meter here and length of the sample is 5 meters. So 3.5 divided by 5 and Z is equal to 4 into 9.81. So if you solve this equation, it is 13.3 kilonewton per meter cube. Only one equation. Okay, so hardly you don't require much if you know this formula. Clear? So this is the last problem for this assignment. So the answer for question number 10 is answer C. Clear? So if you have any doubts, just post your comment in the comment section, and without practicing the detailed solutions, you cannot able to attempt the NPTEL exam. Okay, so you need to practice. Thank you.